Hello world! How is it going? Good morning, good afternoon, and even good evening to our viewers. People from all over the world are watching us today. I'm really happy to welcome you at the launch of a new project that we call JRush. My name is Alice, and I will be your host for today from our partner studio, Chuyko Group. Thank you to each and every one of you of being here with us today, because this is the first experience for us in this format, and I really hope you will enjoy it. We wanted to come up with something that would be interesting to ourselves, to our teams, that would be useful and would not take a lot of time. Large conferences that last several days, they are great, they are wonderful, but surely many of you just simply have no enough time for them. That's why we started JRush. It's a series of web conferences from BellSoft team and our partners, born from our blog and our passion for sharing progressive knowledge that moves the world forward. At these conferences, we will discuss the newest and most interesting technologies, which will create a lot of buzz and cause people to rush out and get them. JRush format, it is only 2 hours that includes Q&A section with the expert, and there always will be only 3 speakers with short, concise, and eventful presentation. But actually, they are not speakers. We call them headliners. Why headliners? This is because these people are always leading attraction in any piece of entertainment, and we will always have such a festival lineup with our JRush champions. And what is more, we will invite only software engineers, those who develop on Java themselves. And today we are starting with a really inspiring subject, native images for Java applications. You will ask me, Alice, why native image, why not JDK 16, for example, because now everyone is talking so much about it. But the answer is in the question. We want to discuss not pop topics, we want to discuss rock topics. We want to highlight the info which is not enough on the net. And well, of course, because BellSoft recently launched a new product, Liberica Native-image key that you saw in welcome letter, and I hope you tested it. But honestly, this is not the main reason. The main reason is that native image is helpful technology to accelerate your applications. It allows creating a progressive and developer-friendly environment. It brings a truly cloud-native approach to Java. But to make it great, we need a certain platform to overcome the challenges. Spring is one of the most notable and widespread frameworks for building JVM-based applications, and Spring Native is a way around certain native images limitation, for instance, when you're working with the reflections. That is why we are starting the native image topic with 3 high-level experts, Andrew Clement and Josh Long from VMware, and Dmitry Chuyko from BellSoft. And our today's conference will be opened by Dmitry Chuyko with his talk Chasing the Grail. Dmitry will anyway touch on the JDK 16 topic for a little, because we need to discuss full muscle support features and ahead of time and Graal JIT. Graal VM licensing model is changing and alternatives appear fast. In this talk, Dmitry will show what you can, in general, achieve with native image. What is more, he will look into the practice of building tiny and performance microservices, containers using Graal, and some other tools. So, future is now, and Dmitry is here too. Let's start with this talk with Dmitry Chuyko from BellSoft.
Hello, my name is Dmitry Chuyko, and we're going to talk about chasing the Grail. Why not just Graal? Because Graal is just one of possible options, what we'll discuss today. And I work at a company named BellSoft. We release and support our distribution of OpenJDK called Liberica JDK. It is a TCK verified distribution. And I'm going to talk about some other products today. And our company is among top contributors in OpenJDK. Why do we do that? Because we like to work with developers and our customers to fix issues and to create new stuff. So developers today like handy deployment using containers. It's very convenient to package our applications as something that's managed by container management systems as an independent entity, as a container, without knowing what's inside, and container just gets its environment. And it's easy to plan how the business logic works in that virtual environment. Then we look inside the container. We'll see some parts of it. Typically layers. Then we talk about layered container images. And of course, the main part for us is the business logic that we write as developers. That's our application. But of course, in all modern applications, there are numerous dependencies. For sure, you will use some framework that does many things for you. Maybe some additional libraries for some specific tasks. And all that relies on Java runtime environment and operating system packages and libraries provided typically in an underlying OS layer. That top part may be split into layers, or it may be united if you deploy it as so-called fed jar. Then it's split it. Such kind of deployment is referred as a thin jar deployment. And also, if you deploy a native image, you again put the monolith part here. And also, you don't need Java runtime part because it's already embedded inside that native image. So it's much simpler. We'll look at just a couple of examples today. Let's create a simple service, almost empty, but that will be ready to use some technologies under the hood. And we'll get a very fat jar that is 37 megabytes. But the very thin part related to our business logic, if we even don't expose any endpoints, just start our application, it's kilobytes. And how do developers bake the images today? Well, sometimes they even don't use images. And here are some polls from Joker conference, the recent one, in 2 different talks. Many people still prefer Word to jar, and many bake Docker files themselves. Some people already use cloud native build packs, and we'll touch that later. And then we create our own Docker files. There are different options how to do that. We always have some underlying base image, and that, for example, base image, if we rely on Java runtime environment, may be called like this. If we pull such an image, like in my current environment where I have 100 megabit network and I have clean repository, the pull will take almost half a minute. And it will occupy more than half of gigabyte on disk after decompression. That's a lot. For example, many developers don't have extensible SSDs, or you think not about development but about production, where everything costs something. Like network traffic is maybe not free, or is not free. Of course, you lose a lot of time then you perform deployment if you deploy many instances at once. Something happens in your system. You waste disk space. Your network may be not very fast. It depends. It may be very fast. It may be cheap, but it may be not. So it's better to save something here. Okay, what can be saved? Of course, we can use smaller container images as base images. How to achieve that? Well, first, we may take not something that came to our head first, but we may take something that's offered during a build process required by a framework vendor. For example, we take Spring Boot and invoke build image command. Surprisingly, what will produce a layered image that, by the way, already contains Liberica as one of its layers. You see it here. Your application will be split into layers, and then we look what's on disk. Then we install that image. Well, it's only it's less than 300 megabytes. That's already much less than half of gigabyte than we saw before. And this image contains your application, not just Java runtime and OS libraries. So this is already much better. And this is a good default to start with. This is a starting point. If you look at different options available for OS environment, they give different sizes than transferred or than uncompressed on disk. And you see the difference is not even 10 times, it's more than that. Among them, there's a very nice special Alpine Linux. So you see, it is much smaller than, for example, Debian, and it still contains C library, it contains package manager, and it contains shell out of the box. So that's something we can use. And we know that it also contains all necessary Linux utilities. So it's quite usable and still very lightweight. There are some peculiarities, like Muscle C library is a different C library than glibc, and BusyBox, the tool that provides functionality of all shell utilities, is different maybe from the set of utilities that we used to. But we are able to perform all required tasks in that environment. So it's good to have JDK running on top of that. Well, it's now possible. In JDK 16, BellSoft delivered JEP 386, that's called Alpine Linux port. That's a new port of OpenJDK that allows OpenJDK to be built and run on the systems with Muscle as their main and maybe the only C library. And this changes are available in OpenJDK mainline, so they form the common ground for all vendors, all distributions that wish to provide such builds. So they now are built using same source code, and fixes are made in the same common repository, and also it is the same mainline repository. So there is no synchronization problem between project repository and mainline. If you look at what we can achieve by using that port and the smart way of building the binaries, you see that the size of a JDK container may be as small as 107 megabytes, and that's for so-called light JDK, which is actually still a full JDK conforming to standard. And it is much smaller than variants of different base OS images, Debian and CentOS. And it's still much smaller than Alpine diff glibc layer, which is called just Alpine here, and you see the smallest one is called Alpine muscle. It contains that special Alpine muscle build of OpenJDK. If you now pull that base image on the same machine, over the same network, the pull will take just 4 seconds instead of 28, because the size is much smaller. And the same happens in clouds or in your private clouds. The baseline for time may differ, but the ratio will be about the same. It is time faster. And you still get a fully functional JDK. So for this functionality, there are many interesting usages besides just JDK 16 and the only platform. The JEP mentions already 64-bit ARM as one of CPU platforms, and that changes were backported, not currently in the updates repository, but locally, and we're able to provide tested and verified builds of JDK 11 and JDK 8 for Alpine muscle platforms, and we do that for a few versions actually. And these changes potentially may be backported to JDK 11, which is also good. On top of that, it's possible to have nice effects. Then you have probably slower network, but much smaller images. You know that you sometimes may be surprised by changes of terms of usage for different public repositories, diff container images. So sometimes it's better to use a private one, like we offer a private repository for our commercial customers. So it contains base OS plus JDK images that you can pull into your organization's repository, append the business logic layers, and then actually deploy to different hosts in your environment in your production. Then you work with a trusted registry. It's very much like a regular Docker hub. You just need to authenticate. Like, please contact me or one of my colleagues to have a demo access there. It's very easy. We'll provide you the username and the password. And then you log in. You have container images prepared specially for your organization. There may be some special ones, like the ones containing hotfixes available after testing. So when you're in, you can use that specific images, maybe containing hotfixes. And also we provide early access binaries and web repositories for the demo. You can try that. They are even more reduced in size, like they are 6% smaller. And they contain additional performance optimizations for beta latency for JDK 11. So please ping me, you'll get access, and you will be able to compare that regular builds and that early access builds with some refinements. So we looked at some Alpine Linux usages and options. How is that useful for users? Well, let's remember the starting point. You can blindly use image build mechanism offered to you by your framework provider, Spring Boot. You can use some blindly some other base image, or you can state some requirements. Like, for example, I want a very quick clean redeploy with clean startup, with very fast startup. Or I need full compatibility, or I need latest Java. That means that you may want to use something like native executable, native image, or you may stick to kind of regular Java SE, regular JDK, and where you also have options how to deploy. Do you need to simply build the fat jar, which is simple in developments, simple. Then you prepare Docker files yourself. Or you need more effective layered jar deployment. Okay, that's also possible. In any case, then use one of thin or fat jar options. You'll have to choose what base OS environment is the best for you. It may be like, I don't want to know anything about any OS, so I don't need even shell or package manager or something. Then you'll pick something called distroless, that is actually a package manager-less environment. You may want to pick something familiar, like Debian or CentOS. Okay, here we offer, for example, Liberica base images built on top of that. Or you may want not something specific, but still containing a shell and the C library and JDK. Okay, you get builds on top of muscle. If you specifically need glibc, for example, you use some native binaries that require glibc as a part of your entire application, it's still possible. You can get Alpine not muscle image with Liberica, which will be a regular glibc build of Liberica, and you can run also some programs that require glibc in that environment, but the image will be slightly bigger. So what about native image part? Are there any options when we build a native executable from our Java programs? Well, there were some options, but in JDK 16 there was an enhancement to remove AUT and Graal as a JIT options as default options for JDK. They're still there in the repository, and they're still buildable, and there are tests that we may run. And in fact, in recent Liberica JDK 16, those features are still there. In recent Oracle builds, they're already not there. And there's a part that is related to connecting Graal, because it's a compiler, JIT compiler written in Java, and JVM itself, the hotspot. This is a JVM CI module. It's still there, and it's not being kind of removed or deprecated, and it's shipped in, I think, all binary distributions. So that will help development of Graal VM, I believe. So in Graal VM and Graal native image space, there is now one more assembly provided by BellSoft that's called Liberica Native Image Kit. And this is a combination of Liberica JDK and all the plugins and native, in particular, Native-image plugin for Graal VM that allows you to build native executables for different environments, including Alpine Linux. And we'll look at it in some details. This assembly already supports many operating system and two CPU platforms. For CPU, it's x86 and 64-bit ARM. It's provided in a binary form. In case of Mac, it will be notarized, and it's very convenient. Of course, you can still use same language plugins. In the case of Liberica Native-image kit, they will be downloaded by the GU tool from our repository. But those are the same builds, same sources of Graal VM tools, just assembled and tested in a way the Liberica Native-image kit is assembled. And the JDK that's inside the Native-image kit, it has regular JDK release update cycle. So it's basically the same Liberica JDK binary that you can download as a standalone package. And Graal VM that's inside, it has regular Graal VM parts inside. They have regular Graal VM versioning scheme. And currently, it's Graal VM Community Edition version 21.0. Then I talk about running that stuff for Alpine. I mean that it required some work in Graal VM project. Some work for tools, some work for languages, some for core stuff. And data support, again, for Alpine Linux as some kind of special Linux environment, and for Muscle C library to make things compile and work in such environment. So how to touch this? You can simply go to BellSoft website, find the download page, select your operating system, select your CPU architecture, and get the binary package with NIC. Very easy. What to do next? Well, let's look at some example. Let's build another simple service, a microservice, the fetch-jar that takes only 17 megabytes on disk. And again, thin part related to business logic written in the actual sources. It's very tiny. And again, then we think about redeployments and Native-image. You won't be able to redeploy it partially. We'll redeploy it entirely. So think twice. Next, what we are going to do. So we started an actual example that can be built to a fetch-jar or thin-jar, or that jar can be embedded to container the Liberica JDK as a runtime, for example. And we're going to turn it into Native-image. So we'll inject Native-image support into build configuration. We'll need Spring Boot Maven plugin tuned. Like you see that exec classifier, this play role here. And we will add experimental stuff, like You see here it is Spring AT Maven plugin. Please listen to the talk of our colleagues from VMware. They will show what actually happens under the hood with that AUT compilation going on. And we also need to add experimental Spring Native dependency. This is the most important part here. The other ones are required too, but this one will do the actual work. So we're enabling native image as one of build profiles. We invoke that native image Maven plugin. And here the central part is we must provide the entry point for our application. It is quite obvious in case of Spring Boot, but here we need to do it manually. You will see that it happens magically without manual edits in maybe next version of Spring, but currently you can achieve that by such manual edits. Then we finally link this to a package phase, and we'll see how actual packaging works. So I will prepare a native image that is runnable in Alpine environment using Liberica Native-image kit for Alpine muscle. So here I take a Docker container. You see I start Alpine. I add necessary build dependencies like libstdc++, gcc, zlib. I provide Java home, and here this is Java home pointing to the volume that I passed to that Docker container that I configured in the run line. And on that volume, there are a few artifacts that are necessary for my build for this particular case. These are Liberica Native-image kit itself, my project itself, Apache Maven. I only need the binary. I already have Java home, and I specify it here. And then I am able to perform the build. You see, I just invoke Maven clean package, profile native image, and then I finally get the binary. And the binary is 57 megabytes on disk. That's more than 37 megabytes as a jar, but still acceptable, and we remember that it doesn't require any JRE. But again, no partial redeployments. If you consider using this approach in your CI, you will probably construct a Docker file derived from Alpine that will have that necessary dependencies added. And also it may contain already Liberica image native kit, Liberica native image kit. And you'll be able to build all your native images using that build container. And how to run the image that we have just created? Well, let's again start the Alpine environment using Docker and using same directory mapped as a volume. And for runtime, I only need one dependency. That's libstdc++. And this dependency only adds 7 megabytes to my container weight. So uncompressed container will be like 7 plus 5.6 megabytes. 5.6 is the base size of Alpine Linux. And I'm able to run my application in that container. Again, if you build for production, you don't need to log into container. You will write an actual Docker file or perform a Docker build and publish your container, and then finally, it's super fast. It starts in just a tiny fraction of a second. And remember that it occupies less memory than the service started with traditional JDK. That's cool. And it all works in a combiner with very slim base layer. That was the goal of this part. So if you want to learn more, or if you want to try the stuff that you've just seen, welcome. Ping me. Go to our website, download Liberica Native-image kit. It's ready to use. You saw how to perform all the steps for building and running, for example, for Alpine Linux. So you can try how your services work there as a native images. Thank you for your attention. See you next time.
Very cool talk, Dmitry. Thank you so much. And I think that Josh and Andy's topic will support it very well. Well, in the meantime, while we are setting up for our next speakers, I will tell you a few words about the chat. I see that someone is already writing here, and please go on. Do not hesitate to ask your questions to our headliners. That's why they're here. And if you have any questions for Dmitry Chuyko, please feel free to ask. I follow everything and will hand all your questions over to them in the Q&A session after the next talk. And the next talk, we will now meet Josh and Andy. They will tell how to optimize your application without risk. We will talk about Spring Native release and create some Spring samples using new Spring Native integration. Then we will run some native Spring samples on Liberica Native-image distro and plug Liberica Native-image into the Spring Java build packs and show that off. So let's learn from our experts and feel free to ask questions in the chat.
Okay, let's get started with this presentation. So welcome to this presentation on Spring Boot. We're going to show you how you can be productive with Spring Boot and how you can take your boot apps and now build them into very fast, efficient native images. So I'm Andy Clement. I'm a director on the Spring team, but I'm also the co-creator of Spring Native. And helping me along on the keyboard is Josh Long, who's also on the Spring team. So I'm going to set the scene a little bit by talking about GraalVM Native and Spring Native. And then really we're going to do a lot of on-the-job learning as Josh is going to drive some demos, build some native images, and we're going to talk about the process as we go. Throughout that, you'll learn about getting started with this stuff. We'll look at some performance numbers in the mix as well. We'll talk a bit about Spring Native extensibility, and then I'll tease the future a little bit because there's some amazing stuff coming down the pipeline. So we're here to talk about Spring Native, but really the underpinnings here is GraalVM Native. GraalVM is a much bigger project, a polyglot JVM style project. We're talking about one little piece of it, which is the native piece for converting your bytecode to platform-specific executables. And that's really the superpower behind what Spring Native is able to achieve. So we're going to use that word a lot, native image. So what is it? So you're used to what happens on the left, where you build your application to compile bytecode, you run it on a JDK and some kind of VM system. And what you do is that is input to native image. So native image will analyze that bytecode. Maybe it's a large executable jar produced by Spring Boot. It'll do static analysis to work out which code really matters. It'll compile that code right there and then to platform-specific executable code. It'll also do some work around the heap. So the image it produces at the end actually has a partially initialized heap in it, and that gives us an opportunity for some optimizations as well. And we're left with this single lump, this executable binary that is specific to an OS that you did the build on, but it's highly, highly optimized. Why would you go through this process? Well, it has some big benefits. You're going to see great memory gains. So using RSS, we'll talk about RSS a bit through this presentation. RSS is the total memory of the process. Unlike heap memory, which is just the bit of the JVM, we like to consider the whole memory here. So we're going to save 3 to 5 times the memory by converting it to a native image. That means cheaper cloud instances. If you're paying your cloud provider to run your applications, you're going to have to pay less now. And it's particularly good if you've decomposed your apps into lots of microservices. Instead of all of them now using expensive JVMs, all across the board, all those images have lower memory requirements. And at the same time, we get instant startup. I say instant, we're talking about tens to hundreds of milliseconds here, much better than the 2 or 3 seconds plus that you might be used to seeing. And suddenly that enables a set of use cases around scaling to 0. You don't need to keep a pool of instances ready to run. You can just start them up when you need them. And what's also important is these are full speed as soon as they start. It's not like an application where you need to wait for it to start up. Then you need to warm it up a bit to processing a few requests. These are ready to go, ready to run. Sounds amazing. Let's do it for everything. Obviously, there's some trade-offs in this picture. So this is comparing JVM and native. So you'll see benefits, startup time, native wins by a mile compared to regular JVM. Footprint, native wins. It's when it gets to latency and throughput that you start to see a bit of a difference. So the JVM has had years of effort put into JITs that continuously re-optimize the application as it's running. We don't have that kind of technology in native images, so they lag behind a little bit here. But the team is working on improvements here to try and narrow this gap. And by the team, I mean the GraalVM team. We work closely with them on making Spring apps work as best as they can as native images. Maturity, JVM's been around for hundreds of years, I think. So we're not there yet with native. It's new, but it's evolving, maturing fast. The place where you'll pay the biggest price is build times. So if you're used to build times of a few seconds, that's not what we're going to see here. We're going to see build times in minutes. And the key things to keep in mind when comparing running apps as JVM apps and running them in native images is that native image is fully optimized. The class path was fixed at the point we built the native image. We can't add classes after that. There is no class lazy loading. I mentioned that it included a snapshotted heap. That gives us an opportunity to run code at build time. So when the image is built, imagine you had a chunk of code that was computing a lookup table and it was going to take a while. And at the moment, you were doing that every time your JVM app started. Now you could run that at build time, populate that table once and have it in the snapshotted heap. But really, all of the magic that goes on here is underpinned by the static analysis that native image does. The analysis engine that they built in the GraalVM native. Starting at that main entry point to your program, it's looking through everything that's being actively used. The challenge is that static analysis is difficult for some of the Java language features like reflection and proxies. They make it difficult for native image to understand what the application as a whole. So we may need to give it some hints, some advice on don't throw that away or don't throw this away. We need those pieces. And we're going to talk about that some more as we go. But just to set the high-level mission for Spring Native, our goal is that you can take any of your Spring Boot apps that you have today, compile them to native executables without changing the code. Okay, so the onus should not be on you. We believe we can make this work. There's a long way to go, but we started off strongly. So with that, I'm going to hand over to Josh, who's going to take us to a very popular place, start.spring.io.
All right, I will share my screen. Okay, so let's do this. We're going to build a brand new application, typical of, representative of the typical kind of application. Here it starts at spring.io. Anybody who knows me knows that this is my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and as often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. And we're going to build a typical application using typical things like JPA, which is a ORM that I'm going to use because I make terrible life decisions. I'm going to use Lombok, which is a compile time annotation processor. I'm going to use the Servlet Web API using Spring MVC. I'm going to use H2, which is an in-memory embedded SQL database. And that's important because I'm not just connecting to a SQL database. I'm also starting up a full SQL 99 compliant SQL database engine in my JVM process. And finally, the secret sauce that makes all this work in the native world is this native dependency. So I'm just going to add Spring Native. Notice that it is experimental. This is not yet GA, whereas everything else in the list is GA. We have down here a couple of choices, but these are not really choices, really. The first of which is packaging. How do we want to package the application? Well, obviously, when the final result isn't going to be something that we can deploy into a servlet container. It's not a .war. You can't deploy your static architecture-specific native image into a servlet container. So it makes no sense to think about it as a war. And .jar, it's more reasonable to think about it like that. It's a self-contained image, but it's not even a .jar either. So these are just, I would just stick with the defaults. It's a big part of my overall and guiding personal philosophy of make jar, not war. And again, lots of things you could do, but I encourage you to select the defaults. Then we have the choice of which version of Java we'd like to use. And again, we're sort of hemmed in between these two different choices and left with but one choice, Java 11. You see, Java 8 is a creakingly old, no longer viable version of Java. It's technically inferior in every way. It's slower, has less features, less syntax, less robustness, less performance, etc. And Java 16 offers a lot of tantalizing new features, but unfortunately, the Graal VM support right now is pinned at Java 11. I hope that at some point at the next major long-term release, they'll update Graal VM to be reflective of that release. But for now, Java 11 is a great place to build our application, so we'll do that. Let's hit generate, and I'm going to open this up in my IDE. Here we are. Let's see here, get rid of that. Generate UAO traditional.zip. Okay, so this is just a traditional application, nothing special, nothing fancy here. And it's going to be an application that talks to a SQL database in terms of an entity, and this entity will be a customer. It's a JPA entity, so I'll use the JPA entity annotation. It's going to have a primary key, private integer ID, private string name, and the ID will be Java persistence, and there's a name field there. That's basically what I want, but of course this is Java, so I need getters and setters and toString and equals and hash code and all that stuff. So I'm going to use Lombok to compile time synthesize all that stuff for me. So I'll use data, I'll use all args constructor, I'll use no args constructor. And now I've got an entity that'll work, but I now need to have a repository, something to handle the tedious, soul-annihilatingly boring read, write, and update and delete data management lifecycle. So I'll create a repository here with two types, the type of the entity and the type of the primary key there. And I then want a component that'll, when the application starts up, will write data to the database. So I'm going to create a Spring Bean. Now, Spring is, at the end of the day, a big bag of objects, and we call those objects that are being managed by Spring components or beans. And so I'm going to create an initializer bean that implements an interface that when Spring sees it, will signal that it wants a callback, right? So Spring will see this application window interface, and it'll see that we are implementing it, and it'll call that when the application is ready to be put into service. And when it's ready, we're going to write some data to the database just as a demo, just to see that everything is working. We're going to synthesize a constructor based on this, a constructor that'll accept a reference of type customer repository and then store it in this final field using Lombok's required args constructor. And here we're just going to write some data. So we'll put some people who are on the Spring team in this list of names here. So obviously Andy's on the Spring team. I'm on the Spring team. Madura, she's on the Spring team. Olga, she's on the Spring team. Yushin, she's on the Spring team. Violetta, she's on the Spring team. Stefan, he's on the Spring team. The good Dr. Sire is on the Spring team. And then for each one of those names, all 8 of them, we're going to create a new customer, passing in that. And then for each one of those, we're going to take the customer and write it to the database using the repository. So save customer. And we're going to store that whole thing into the database. And we're going to see the results as they come back. And in order to do that, I'm just going to invoke the terminal function, the Java 8 streams terminal function for each, and that'll print out everything that gets recorded. And that'll give us a simple example. And then I want to create a simple REST controller, an HTTP controller using Spring MVC, customer REST controller. And we'll introduce the private final customer repository. Again, need a constructor. And this is another marker annotation, a stereotype annotation for a component. And it tells Spring MVC that this should be exposed as a HTTP handler. So customer get return this customer repository find all, and we're going to run it again. Now this is going to fail the first time I try and run it because I'm inside of IntelliJ, and IntelliJ doesn't know about some of the code generation that's required to support our native image efforts. In particular, it's going to say that we are missing this thing called static Spring factories. In order to get that, the easiest thing seems to be just to generate it ahead of time using the Spring AOT plugin, which we'll get into in just a second here. So I'm going to do Maven Spring AOT generate behind the scenes. Let that run. And we need to tell our project to reload itself from the disk. So reload from disk. We can see that file, that class is now in the output files here, right? So that's what it's done, is generate this text file. We'll come back to that in a second. We should now be able to run it. Let's see. Sometimes it's not clear. Sometimes you have to retry. Okay, what has just happened? We must manually instantiate the entity, the ID. That's not a big deal. So we'll go here and say @generated value and restart. Okay, there's our application. There are our 8 records, and we go to the browser, and you can see the results in the HTTP endpoint have come back just fine. So we have a JVM application. It starts up in a respectable, almost 2 seconds. Bear in mind that I'm actually doing a screen cast, and that's, it's taking a lot from my CPU. So this would start up a little bit faster without the screen share. But nonetheless, that's where we are. So I want to turn that into a native image now. And I'll go to the command line here. I'm going to run maven clean spring-boot :build-image.
Okay, let me talk a little bit while that's running, because it's going to take a little while. So what did Josh just do? He ran Spring Boot build image. So that is it's been in Spring for a while now. It's a way to convert your Java application to being a container. And it uses Paketo build packs to do that. All we're doing, if we can look in the POM, is we're tweaking that behavior. This is what start.spring.io did. It noticed we used that Spring native dependency, so it tweaked the configuration of the build pack to set that flag to be native image true. So that will mean that as a final stage, as it's building that container, it will run native image and try and give us an optimized executable. Notice also that reference to Paketo build packs tiny. That's because to support a native image, you don't actually need a full-blown Linux like you might do for a JVM. So it's also going to create a minimal container in that the executable will be tiny, but also the OS underneath it will be the minimal set of packages to support that. So this is a way to really create optimized containers here. Now, I mentioned native image is going to throw stuff away, and native image doesn't understand how frameworks like Spring are using proxies and resources and etc. and reflection. So that is what Spring Native does. Finally, 20 minutes in, you're learning what Spring Native is. It is, if you think about native images doing a Java analysis of the world, Spring Native is doing that from a Spring point of view. So Spring Native understands auto configuration, dependency injection. It understands that application.properties needs to be included in the image because it will be used to configure the application at runtime. So Spring Native does an analysis before native images run. It works out what is required, then creates that extra configuration we talked about that is passed to native image to say, don't throw this away, you need to include this. And so how does Spring Native get invoked, given the way the build system is right now? And that is where we get into the AOT process. You see Josh highlighting the section there. It's all covered in the docs, what you need to do in here. Initializer did it for us, start.spring.io. So here we are. AOT stands for ahead of time. It's a framework built into Spring Native. We're incubating it in the Spring Native project, even though it has broader applicability. It's a way to execute code after the application's built, to do stuff, generate code, take extra steps before the packaging occurs. So right now, there's a couple of things plugged into it, one of which is Spring Native. So the build finishes, the AOT framework says, does anybody want to run? Spring Native is something that wants to run, so we get a chance to analyze the code, compute that configuration for native image. And the output of that, the way those two things communicate, is via a series of JSON files that we'll look about in a little while. So there is another thing that we plug into that IoT framework right now. The static Spring Factories file is also generated. You saw Josh doing the generate of that. He mentioned when the file was missing. Static Spring Factories is a programmatic representation of something called Spring.Factories. Now, Spring.Factories is normally a text file resource that Spring uses to work out which configurations to load at runtime. So typically, it reads that text file and uses reflection to load those classes. We talked about reflection not being good in a native image world. So we have another IoT plugin that is trying to generate code from that Spring.Factories file. And the benefit of having code is that native image understands it directly. It doesn't need any hints. It can see what is happening. This means Spring Native doesn't have to be as smart, doesn't have to produce as much configuration. And that extra, taking this further, hopefully you can see some of the possibilities here, is that many configurations in Spring are conditional on the presence of something on the class path. Now, we've already talked about when you build the native image, the class path is fixed. So what we can do is when we generate this static Spring Factories, we can look at a configuration. If it's conditional, we can do that check there and then about whether that class is around, because it can't be added later. So if it's not around, we don't even need to include it in static Spring Factories. So you get a codified version of Spring Factories, but also optimized in that things have been thrown away that will never be used. Compare that to the old model where the JVM would be loading them up reflectively, then checking the condition, and then finding out that it didn't need it. So all these things add up to trying to produce a more optimal image. And we expect to see more of the portfolio plugging into this AOT framework over time. Last things I wanted to touch on were, if you go back to the POM, there was a Hibernate section in there. And start.spring.io knew that it needed to tweak Hibernate a little better to work optimally in a native image. So that's what this extra configuration is here. But this is a broader problem too, in that applications aren't just made up of Spring libraries. There are other dependencies in there. There's a Netty, there's a Tomcat. All these things need configuration if they're going to behave as a native image. So if you look at what Netty has done, for a while now, they've been shipping configuration. So we don't need to compute it for them. They're providing it. Tomcat, we worked with the Tomcat team to compute the optimal configuration, and they now ship it in their jars. So we don't need to compute that either. So we want to pursue this model of working with the community, and anyone out there who needs a dependency to work a little better with native image, we can help you work out what that configuration is, and then all the Spring users using that can benefit from that, sharing that configuration amongst ourselves. So with that, are we any closer to the build being finished, Josh?
Nearly there. You can see it's taking its sweet time. This is a very complex application for Spring Native to analyze. It's using the full servlet and JPA stack and all the sort of dependencies that are implied by that. So this tends to take longer than most applications that I build these days. I typically tend to use the reactive stack, right? I use reactive web support, reactive data access, and so on. And so that tends to be almost half, in terms of build time and complexity and startup time. But this took 6 minutes on my machine, and I've got a pretty hefty machine here. But we do have a Docker image. Keep in mind that it took 6 minutes and it takes lots of RAM because I'm running the native image compilation inside of a Docker image. So I need Docker daemon. My Docker daemon, my Docker desktop has to have a lot of RAM, and then that's used by the native image support here. So this is not going to be something you want to try on a Raspberry Pi or something like that. So let's run this image. There we go. So it took a second to initialize the Docker container, I guess. I'm not sure what that delay was, but for the JVM application itself, it's almost just about two tenths of a second. 20% of 1 second to start up. So hit Control C, run that again, etc. There's 2/10. And I can actually publish the application port. Voila. Go to the browser, refresh. There it is there. So very, very, very efficient, very, very fast. We got the results. I typically see when I do reactive applications using the reactive HTTP support in Spring and R2DBC and or something like RSocket, you can get applications that are down to less than a tenth of a second. If you do RSocket, for example, just by itself, that can be well under 0.050, so 50 milliseconds, not 200 milliseconds, a quarter of the startup time for something like this. Very fast. We'll talk about performance in a bit, but at this point, we've just shown you something pretty typical, pretty representative of a lot of different applications, JPA, web, that kind of stuff. And that stuff should just work fine out of the box, right? It should be fine just out of the box, no problem. But the problem comes when you experience something that isn't typical, when you want to do something that, for example, we haven't already shipped support for. So let's build a new application, going back to start.spring.io. And here we're going to build a new application. We're just going to call this demo. Okay, it's a very typical, very trivial application. I'm going to bring in the native support. Native support. I don't want the reactive web support. I want the native support. Thank you. And I'll use Lombok. And that's it. I'm just going to hit generate. And that'll give us a new zip file that I can then open up. And when we start this application, we're going to look at a few corner cases that we admit are fairly contrived, fairly artificial. You shouldn't normally be in this territory, but it's just very good to know that these things are there, so you know the recourse that you have if you ever experience a situation where it's just not working. And thankfully, there are some tools, as we'll talk about in a minute, that can give you guidance on what has gone wrong. But there are some cases that Andy just enumerated, some cases that will cause trouble. For example, reflection without upfront configuration will be a problem. Dynamically registering classes in the class loader will be a problem. So let's suppose I have an interface called animal, and that interface has a single solitary method called talk, and I want to create a proxy of that. Now, a proxy is a thing you can do in the JDK, and who knows, you might go your whole career without realizing that there are some things that are not as they appear to be. It can walk and talk like a duck, but it's not actually a duck, and so a proxy is one of those things. You can easily create proxies in Spring using the machinery behind the scenes, including the proxy factory bean. Now, the proxy factory bean is it's been part of Spring for forever, right? The whole proxy mechanism has been part of Spring forever. And the idea is that you can decorate an interface and add functionality to that interface or to an implementation of that interface as advice. And so there's one here called the method interceptor. This is part of the org AOP Alliance. So Spring 1.0, back 18 plus odd years ago, had support for this, and that's what precedes Aspect J. Andy here works on Aspect J, which is, I think, if we talk about AOP programming these days, I typically point people to that. But so we're going to add an interface, we're going to add the advice, and then we're going to get the object that's created as a result of that, the factory object. And the benefit of AOP, of this advice support here, is I can now intercept method invocation. So when somebody invokes a method on the resulting animal, it's going to get we're going to get a chance to intercept that invocation and do something with it. We can swap out the return value. We can do something like that. So here's the return value. We're going to return normally. We're going to forward the method invocation to the underlying Java Lang object. But if the method that they're invoking is the one that we've implemented or we want supported on our animal interface, then we're going to intercept that. So if it's equal to talk, then we're going to return our own value. We're going to say, hello, Spring Native. Okay, so very, very simple, very trivial proxy. And I'm going to exercise that proxy by using a component again. I'll register another component. By the way, earlier I showed you at component. That's a way of registering an object with Spring, a class that Spring will turn into an instance. Here we have an alternative way of doing that. Here we have a method that returns a value. That object that we return gets registered with Spring, but the result is the same. At runtime, there's an instance of an object being managed by Spring and made available for use or injection into other objects. And so as before, we'll create a component that implements application listener, or application runner, rather, pardon me, application runner. And we'll implement that interface, and we're going to inject a reference to the collaborating object, this animal here, and we'll do so using Lombok's compile time synthetic constructor there. And we'll just say that the result is equal to this.animal.talk, and I want to print out the result. Alrighty. So as before, before we can run this, we need to make sure that we run the AOT plugin, Maven clean spring AOT generate spring :boot run. There we are. It's worked on the JVM, right? So we can see it's just running on the JVM there. Our application is done as we expect. It's a fairly trivial example, but this won't work as a native image. And it's because Spring Native has no way of knowing about what animal is. It doesn't know that that's actually a proxy. It's not just an interface. It's actually a thing that needs to be proxied. So let's kick off that. Maven clean spring boot :build -image.
Yeah, let me just talk a little bit about what is going on there and why we're having trouble. So proxies, I mentioned early on that you can't add classes to a native image once it's built. It doesn't allow it. But JDK proxies are a special case. So there are different forms of proxy. JDK proxy is a relatively simple one that's just interface based. And it's built into the JDK. So there is support for JDK proxies if you tell native image when it's constructing the image that you're going to ask for that proxy later. And so if you provide that configuration early on, it will build one, include it in the image, and then when you request it later, it will return it to you. So what you can see here, Josh has loaded the proxy config.json file, and these are the ones computed by Spring Native for you, so you don't have to worry about them. And it's just a list of groups of interfaces. So for each group of interfaces there, a native image build time, a JDK proxy is built and included in the image. So when requested later, it gets returned. The problem is when native image doesn't understand a proxy is involved and Spring Native doesn't either, then it can fall through the cracks. And you'll get an error at runtime. Someone's making a request for a proxy and nobody told me about it earlier. So that's the problem we're trying to address here. Now, cglib proxies, which Spring also uses, we're trying to use them less, but they're not supported right now. So because they're more complicated beasts, they tend to allow class-based proxying. They don't work very well. So we're still working through some issues there, but we hope to have a solution that means you won't have to change your code at all. So is that now finished?
It is, and I would just say that when you're using Spring Native, unless you have a very specific case where you need cglib proxies, you won't know it's missing. I don't know how many people were aware that that was an option before, and the fact that it's not and everything still works is pretty nice. There we go. So I ran it. I compiled it. It built, but it failed at runtime. And when it failed, the runtime spit out this very convenient bit of information here. It says that there's a nested exception. The proxy class defined by the interface animal, which in turn also implies Spring Proxy, Advised, and Decorating Proxy. All those interfaces are not supported. It doesn't know how to proxy those yet. So we need to use a little framework that's built into Spring Native to extend the configuration, to augment the configuration that Spring Native picks up by itself, to contribute to that. So we can create a proxy hint. And this is one of a handful of annotations that you can use. And you typically put those on your Spring Boot application annotation, right? So if you find your Spring Boot application, plug that in there. And notice that the output there gave us 4 interfaces in a particular order. That's very important. That order is actually critical there. So class, animal, and then Spring Proxy, and then class, and then decorating proxy. There we are. So there's our 4 types. Let's go ahead and rebuild that. Worth noting is that the types here can be type names as well. You can actually, I could have stipulated all 4 of those types as strings, right? Clean up the mess there. I could have done that and so on. You get the idea. That's great for types that aren't visible, that you can't reference because they're package private or just private or whatever. You can reference them by their string representation form. Can you represent package classes that are inside of a container type?
You mean nested classes? Yes.
Yeah. So you do like $, something like that. I'm not sure what we put there. Okay, so the build has finished. There it is. Whoop. There we are. Docker run. There we go. So that worked just fine. Now, as a matter of polish, I don't normally like to just system out print things. So I'm going to use a logger, and Lombok has this convenient annotation to introduce a synthetic logger. So I can actually just now do log.info. The problem is that this in turn is going to bring in some other classes that will also cause issues. And those classes, I want to teach my application about them, and I can use type hints, right? So the type hints I can use are for two classes: default flow message factory.class and reusable message factory.class. That's the type hint for those. But I only want to register those because Andy cautioned against adding extra things for no reason. If we don't need it, we don't want it. So we can actually wrap this type hint in a native hint, and that in turn has a trigger. So I can say when log4j2.class is on the class path, then and only then do I want to then activate this type hint. So I say types equals like so. Now this type hint is actually pretty generic, right? I can imagine wanting this to be in a centralized place, ideally Spring Native, but not everything can go into Spring Native. And so you can actually package that up into a separate jar. So what I'm going to do is I'm going to go here and create a new jar called hints, to which I'll add my native support and Lombok. Then I'll hit generate UAO hints.zip. And this is just going to be a regular jar, nothing particularly fancy about it. We're going to get rid of all the Maven plugins for building Spring Boot apps, and we're going to add in a class here. Goodbye to this, goodbye to that, goodbye to that. Keep it small. Add a new package called hints, to which I'll add my log4j2 hints class, which will extend a type called native configuration. I need to add this to the class path. We'll do that now, and I'm going to paste in the hints that we just worked on. The only other thing I need to add to this is this AOT dependency here. Okay, and I'll bring in native configuration. Maven reload project. Okay, we're going to import, and this type is just an interface we can implement. And of course, there's other things you could do. You could actually dynamically contribute hints if you like. I'll just leave that to you to do. You can actually register custom hints, but Spring Native does this all the time. We register custom hints dynamically as well. So I'm going to install this. And now I've got this dependency that's going to be on my local repository. But you can, of course, publish that in your Artifactory or Nexus or whatever. And then you can add that to your build. You can add that to this as a dependency in the AOT plugin. So I'm going to go down here very quickly. And I'll say dependencies, dependency, and voila. And that would actually, now if I built the image, this would work. And I don't have to actually add it redundantly to each application.
Okay,
Andy?
let me finish off with some slides then. Wrap everything up that you've seen today. So just a quick section on performance. What kind of numbers are you going to see if you do this for your own application? So you can see here we had a sample actuator RDBC Webflux. The memory goes down. If you run it on the JDK, it's about 640 meg. If you build it to a native image, it's down to 86 meg. Clearly, you're paying a high price for the build time, but you're recovering that in terms of memory usage. And look at the startup time. It's down from 3 seconds to 100 milliseconds. Similarly, if you go traditional with a Pet Clinic Tomcat app, you save hundreds of megabytes of memory again, much faster startup time, pay for it in build time. So I hope you can see the pattern here. And this slide is just reinforcing that the numbers you see today and the numbers we've seen from Josh's apps aren't where we're finished. They're just the current point in time. So for example, in this gap between 2019 and 2021, we did some work to bring down executable sizes for native images by 20 meg and memory down by 7 meg, half the memory in the Webflux Netty case. And the build times have come down too. That's a combination of work we're doing to make Spring Native smarter and work the Graal VM team have done to make native image smarter. So expect to see more of that. You can try this out now. We just released 0.9. The 0.9 branches are going to follow Spring Boot versions, all on a Graal VM 21 baseline. All the docs are there for you to go and try it out. Big performance improvements in 0.9. It uses that AOT framework for the first time. These are the starters already supported. If you use these, you're probably going to have a good time. If it doesn't work for you, maybe it's missing some configuration. You can work with us to craft the missing stuff, and we can fold it into Spring Native. I think the mail starter support, for example, was coded by somebody else and contributed to the project. So those 0.9 releases, we're going to chase Spring Boot versions. So you'll need to use the right one that matches Spring Boot version. And we're going to keep up with new versions of native image as they come out. Looking further ahead, 0.10, 0.11, you're going to see Boot 2.5 support, but also this something here, automatic conversion of existing config into functional config. I just want to finish with a taste of the future on what that means. So on the left, I have traditional annotation-based config, and on the right, I have functional config, which has been in Spring for a while, but it's not widely used. And it's basically being more programmatic about registering beans in a context. Now, native image loves the stuff in native functional configuration. There's no reflection to try and work out what's happening there. So it can make a big difference, as this example shows, to your application. So I've got a WebMVC Tomcat application here, and you can see this is the native image normally, but if we convert that to functional registration, we save another 20 meg of memory. So this has promise for the future. Now, I'm not saying you should go and rewrite all your applications now to functional registration. That's not the idea. We think we can automate that transformation, and there is a project in the Spring Project Experimental org where you can have a look at what we're doing there. So there's a bunch of resources. Google is your friend for finding us. There's a good article on spring.io blog for learning more. We're at GitHub if you want to contact us. Always go to start.spring.io if you want to start playing with this stuff. So with that, I want to wrap up. Thank you to Josh for all those cool demos, and I hope you enjoyed the session with us today.
Thank you.
Guys, this is a very useful talk, I think, and I will definitely send all the materials to you after the conference. You can see all the videos again, and you will have all their presentation from our headliners. And please follow Josh and Andrew on Twitter. Their Twitter account you can find on our JRush page. And now let's get all our speakers on the air and start the most interesting part, the Q&A section. We have collected a bunch of questions from our subscribers on Reddit, on Twitter, Stack Overflow, Discord, and other channels. And what is most interesting, our headliners do not prepare for these questions. They didn't saw them. They didn't see them. And I think it will be interesting. So let's see. Hello, guys.
Hello.
Hello, hello.
Yeah. Well, let's start from the first question. Dmitry, I think it will be for you. Just how do you like Josh and Andy's presentation? What can you add in using Liberica Native-image plugin?
Well, I like it very much, especially I follow how this story develops all of the time. So each half of year, there are updates on new successes in Spring and Native Image, making their road together. Like the one they saw in last autumn was very impressive, and now new results are even better. So that's really, really cool. And you see the movement of making it much simpler for a developer. So making less configurations, less code, just take it as is, use Builder, you get it working.
Okay. Well, thank you, Dmitry. Let's move to the next question, general question. It's a question from our subscriber on Twitter. He just wants to ask you in a quick way, all of you, to give the top 3 reasons to stop everything that he's doing and try a native image. Why should he do it? Well, let's start from Josh.
Top 3 reasons to try native images. It's better resource efficiency at runtime, which I like. It helps you prune your class path, which is a nice exercise. It is springtime here in half of the planet, so spring cleaning is always in order. And then third reason, what's the third reason? What's a good third reason? Andy, help.
Startup time is the good third reason.
Is that a good reason? Yeah, I guess that's a good reason.
Well, if you're working on serverless use cases,
It's true. It's true.
and it does facilitate the scale to 0 option.
And Dmitry, could you add something?
Yeah, a couple ones. Of course, you get smaller static footprint than a jar plus runtime. That may be your case. And another one is kind of mental one or about your career. So this may be a next big thing in this part of technology world. So the earlier you learn it, the better it is for you.
Okay, got it. Thank you. Let's move to the next question. It's for Josh and Andy. Andy, you talk about use case. So are there any famous businesses that use native image in production? Maybe you can tell us.
Well, we're working with a few groups right now, but I've heard things, and I think Josh can fill us in a bit more on. Alibaba are doing stuff with this. It is not such a mature technology, obviously not as mature as a JVM, it's been around forever, but it's maturing so quickly, and we're seeing so much interest from groups who want to adopt this for those reasons we just talked about. So Josh, did you have any extra info on that Alibaba?
Yeah,
scenario?
I know. I think I saw that Alibaba did tests they have this big. Alibaba is a e-commerce engine in China. For those who don't know, they have a sales holiday, a fake holiday, kind of like what's a good one, like Cyber Monday. In the West, we talk about Cyber Monday, which is it's a day where people buy sales at cheap online, and there's also Black Friday, which is a sales holiday as well in store. And these are like reasons for people to go spend money. In China, they have something called Singles Day. It's 11/11, November 11th, and the Singles Day is crazy. They do it's like $30 billion in 24 hours or something like that. Like, more than Amazon and eBay combined on Cyber Monday. They do more than that in one day in Alibaba. So whenever they do anything at all, even just a small amount of it, it's huge, right? So they, over the last 11/11, I think I heard that they ran some workloads as native images on Grail. So that's really amazing. Right?
Okay.
It's not everything. It's not production. It's not done, but it's a lot.
Okay, thank you, Josh. Well, the next question is for Dmitry. Dmitry, so we can't name a lot of projects, a lot of companies that use a native image. We understand that it is an experimental project. So, but what do you think is native image is production ready for everyone?
I think not yet.
Mm-hmm.
Yes, you may be sure if you try to get it with extra support, as not just blindly switching, but of course you need to test. And there are many open issues. There are many plans, so there is not covered by existing functionality.
And
can I add a little something?
Yeah, of course. Welcome. You're welcome.
Dmitry touched on it. Is that testing story? Right now, the testing story, you're used to it for JVM. It's JUnit and things like that, and it works really well. And then you've built this beautiful app. You run all your tests against it. It works perfectly. Then you run it through native image that turns it into something else entirely. Can you be confident that that still works? And you're going to have some black box tests that are fine, but wouldn't it be nice if you could test to check the thing that you've done still behaves? So we are actively working on that area with the GraalVM team to come up with a a way to run your tests inside a native image so you can be more confident about the thing you're going to ship.
Cool.
And we see that as a key part of the maturity story.
That's really
Yeah,
cool.
exactly. I would repeat exactly that. So if you use some tool like JUnit or something else, that you're just able to run inside a native image, for example, that doesn't mean that it works correctly. So you need to be sure that this version of the tool is kind of tested, especially for native image.
Okay, got it. We can talk about the future more. Maybe Andy and Josh, could you tell us about your plans of Spring Native?
Andy?
Yeah, well, I showed a list of supported starters. So if you're playing with those starters, you're going to be in for a relatively good experience. But there are so many starters out in the world for different pieces of technology and their integration with Spring. So over the next few months, we expect to expand what we've got. And some of the stuff Josh showed around type hints and so on should make it easier for folks to craft some stuff. We've even had contributions already where people have added support for starters. I hope to see more of that happening. So you're going to see that improve, but at the same time, we're incubating things like that AOT framework, and we hope to push some of this down into Spring Framework and Spring Boot over the Spring Boot 3 timeframe. So it's even more, works more seamlessly out of the box. So we've got a lot to do, but we've got a good base here that we can move from. Yeah, please try it out.
And the benefit of that is not just that we can do more, but with those tools, like you just said, with the type hints, with the framework, now people can help themselves too, right? It's they can build if they need to.
Yeah, got it. One more question about plans. Are you planning to support records and other new Java features in Spring when there are future native image versions based on JDK 16 and 17?
I think, yeah, absolutely. Oh, go ahead, Josh.
Well, that stuff is supported in. You can use Java 16 today, and we have some stuff in Spring Framework that uses records, and I think Spring Data is aware of records as well. So, but as for native images, well, obviously that's a different story.
Got it.
Yeah, as soon as Graal VM catches up, we will pick that up, and it should just be fine.
Thanks. And Dmitry, what about the plans of BellSoft about Liberica Native-image kit? What will be the future of this product?
Well, it's present. You can just go and try it. If you're interested in like support or something, just contact us. And I think it is a very important part. What I tell in my presentation is that you have options when you, for example, deploy in containers, deploy in cloud. And this is an important part of this universe.
Okay, got it. And can you describe the native image development roadmap?
Of course, pick next versions, bring bug fixes. The support for Alpine is not yet entirely completed. So that's the next, the closest thing to complete. And there's a big room for optimizations.
Mm-hmm. Got it. Well, thank you. Let's see some question in our chat for Josh and Andy. Would it be possible to debug the application built in this way? In this way, I think our viewer just mean that you told in your presentation, in your talk. What about hotspots? Are these optimized in the same way as with static analysis or different?
We can tackle that from the Spring angle. First, I'll touch on the debugging. You can do debugging of the native image. I have seen it. It does exist. You can point it. You have to dig out some 90 skills and break out your GDB, I think, because it is a binary. But you can step through Java code. Obviously, there's no hot swap there or anything, so you can't change classes on the fly. But you can debug it that way. What was the second part of this? It was...
No, the second part, wait a second, please, about hotspots.
Oh, yes. So part of the maturity story, I think, is that the JVM has all this years of experience with rejitting stuff on the fly. So it can optimize as the traffic changes, it can rejit itself and improve over time. We don't have that kind of stuff in native image yet, I don't believe. Maybe Dmitry knows more than that. So that's why on one of my slides, you'll see there was a gap for that throughput thing. But I think native image is early days, so there's plenty of time to catch up.
Got it. Josh, would you like something to add?
Nope, perfectly well said.
Okay,
I can append
Dmitry
some,
has something to
yeah.
add.
Just a kind of how it can work technically right now, right? There's, I think, profile guided optimization for native image. So you have two different profiles. If you're able to distinguish what happens to your traffic, so you have some monitoring that says, okay, this instance doesn't work very well, and you know that you have a different profile of your load, then you can switch to another statically compiled one. So you have two versions, and you just reroute your traffic there. That's what you can do right now, but you have to have very sophisticated monitoring and decision system. How to control it.
Okay, thank you for that. And talking about monitoring, we have some more questions from chat. Native image seems to rule out using New Relic for monitoring and observability. Sorry, any workarounds?
For any of those things that are doing kind of bytecode manipulation, if you can do it early enough, like just before the image is built, you can still use them. So if it's post-compile step, I'm thinking here of something like aspect J, class weaving, or even load time weaving as the image is built, you can do it. But right now, I don't know that there is a story for doing it later than that, doing it runtime.
Got it, thanks. And Dmitry, will be Liberica Native-image kit accessible from SDK man?
I hope yes. So we like it a lot, how it works with Liberica. So if it is not yet available, I think, yeah, it will be available. And a related question is the accessibility via, or discoverability via the Discovery API. That's what we are working on right now. So as you probably know, and there's Discovery API for Liberica and other stuff, and guys heavily prepare how native image kit will be embedded into that API. So that's for convenience for everyone who consumes it in some automated way.
Got it,
Including different package manager systems like SDK man.
Okay, thank you. And the next question is to Josh and Andy. Is it possible to build native image with Graal polyglot?
Is it possible? Oh,
I think it's possible. I think we've been so preoccupied with the Java thing that we haven't explored that space yet, but it should be possible. We're not doing anything strange here in the way we are treating native image.
And Dmitry, what do you think?
Yeah, sure. So it is the working part, right? So the question is basically, I think, if it's simplified, can we use some Python, R, or JavaScript code in Spring microservice? I think the answer is yes, using that technique.
Okay. Well, the next question is about UTF-8 support for Josh and Andy. If you would like add, please. Is there an issue with UTF-8 support with native image, or is that just needs some configurations?
UTF as in like
the character set
encoding?
Yeah.
Yeah, okay. There are issues?
Josh, let's start.
Sure,
Let's
I
do
got
it.
nothing. I don't know.
You don't
A
know.
couple of years ago, we had a lot of problems where you couldn't make Spring apps into native images for one reason or another, and it was things like character sets were missing and things like that. I feel like we've pushed past all that now, and a lot more stuff is just working. So gone are the days where you just can't make it work or native image will just crash. We're in a much better place now where with that bit of with magic like Spring Native and some manual configuration, you can make most things just working. So
Okay, thanks.
I don't think you'll have a problem.
Okay. Dmitry, where can we learn about Alpine Linux-based container images?
Well, that was the topic of the presentation.
Yeah, but our viewers have this question. Maybe you can answer just in one sentence.
We're going to publish some information on dzone, right? Can we announce it? Yeah.
Yes.
Yeah, so there will be a number of materials available in our blog and on other resources related to the topic. Basically, it is very simple. You just need to know that there is a binary that works for Alpine that allows you to build a native image inside Alpine environment, and the result is runnable there.
Mm-hmm.
As you saw, it is very easy. It's just another type of system, but it is very small.
Okay, thanks. Josh, does it support XMX kind of options in the same way as GVM does? I think it's a native image. No?
I'm going to ask Andy. He's my point of friend.
And I may defer to Dmitry in a minute, but we don't take control of the memory controls like that, like you're used to for JVMs when you're managing XMX, XMS, and all of that. We don't worry about those so much. We leave it to native image to do the right thing, and so far it's doing the right thing. Dmitry, do you know anything under the covers?
I thought it has some grips, like it's called probably like native XMX or something. So
Cool.
It's more or less the same because it is substrate. Substrate gives you a managed environment. There's a garbage collection, so it's not a problem to have kind of different heap sizes, not fixed one.
That does ring a bell with me, but maybe I've just been lucky that the defaults have just worked for me, so it's not something I've had to worry about too much.
I've been so amused by how small my memory footprint is. I never thought to try and constrain it because it's never been a problem I needed to, you know.
Got it.
That's true.
And talking about something that is not working, we have some more questions from Reddit. I'm trying to build my app with native image. Is there any quick check or something that marks I've done it right to go on with detailed testing? I think it's a question for all.
I wish there were.
But
really, it would be nice to check that everything you've got is correct before you suffer that giant native image run that's going to consume all your RAM.
All of it. It's like Slack.
There's nothing perfect there right now. I think it is something we have to work on and improve. Hopefully, more stuff will just work out of the box. But we're not there yet. So there is going to be some, depending on what you're doing in your app, some of it may just work and you don't have to do anything. But if you're using those starters beyond the ones we bless, they may need some manual configuration. Build times are always coming down, so maybe that native image thing won't be so bad in the future. But it won't get down to a couple of seconds, I don't think, not without something radical changing. But
it would be nice if at the end of that long, arduous build, there's something more affirmative about the success of your build, something like the party parrot, something to say it worked, congratulations, fireworks, all that kind of stuff. Right now it's very depressing. It's warning, 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 warning.
Warnings.
And then small letters build success, like, oh, okay. My hair grays every time I do a build.
I'll say there was a version of the agent once. If you think about what the agent does, it collects config as you run the application. There was a version of the agent at one time where you could turn on a flag and it would turn into a policing agent. So then it would look at the config you had and you would exercise the app. And if you did anything that config wasn't covering, it would fail immediately. So you know something's missing. But we didn't go too far down that road. Maybe we'll resurrect that. It's definitely a place we have to get better at, because this round tripping of waiting 10 minutes for something to go wrong and then fixing that thing and 10 minutes for the next thing is not great. We know he's got to work on that.
Okay.
It's nice, at least with the AOT plugin, that you can look at the output before the build.
Yes, that's definitely
if you know what you're looking for.
We used to always, previously, before we had AOT, we were a plugin for the native image process itself, a feature. And we would dump out the configuration we were computing, but only at the end of the native image process. So if you were worried about whether it was considering something in your configuration, you could only check after 10 minutes. But now, as Josh said, when you run that AOT generate, it's producing the configuration right there. So you can go and inspect it before you run native image, if you know what you're looking for. That can be helpful.
Okay, thanks. And how can I know what I'm looking for? We have a question. Is there a book that you recommend where I can learn more about native image?
I don't know anyone's written one yet.
I'm working on a very long blog post, but that's still not going to be enough.
Yeah, you're going to see materials coming out from us. We're always working on our documentation. It's very important that we have that, particularly the troubleshooting section. And I see in the issues that are being raised that we've got some work to do on helping educate. When you hit this problem, this is the solution. So when you hit that again, that kind of thing, you can self-service and fix it yourself. We're getting there, but I don't know. It must be somebody writing a book, but I'm not aware of who it is. Is it you, Dmitry?
Maybe you plan to write a book.
I would say that there are different topics. First, the theory, how such IoT virtual machines work. So
Yeah.
what's the tech side, and the absolutely different world. Not absolutely, but very different. How it behaves with a particular framework, like Spring Boot. What are pitfalls in this area, and they're different.
Okay, thank you. We have some provocative question, I think, but I think that I should ask you. Are you liaising with other suppliers to make sure their boot starters are native compliant? For example, Microsoft have a lot of Azure Spring Boot starters.
We are talking to other groups, because if you think about the problem, we can't solve it all ourselves. We're a finite team, and there's always people writing new starters for new technology. You kind of have to be an expert on that technology to write the native image configuration for it. So we're about working with groups, educating groups, providing material to help those groups self-service, so that down the line we can get out of that business and concentrate on just the needs of framework and boot. Right now, we do have our own configuration for some libraries where they aren't providing it, but obviously down the line, we'd like to hand it over to them to say, we've had a first stab at this and this works, but maybe you want to polish it or optimize it and maintain it in the future. And we expect as native image becomes more mature, we'll see more of that. And Microsoft are one of the teams we're talking to about what they've got.
Julian Dubois has done some demos on Azure functions with Spring Cloud Function and native images as well.
Isn't it possible to make a static analysis tool that will say that something is not fully compatible in the starter that's used?
That is possible. That is possible. But we're in a much better place now, as I mentioned, where more things can work. There's only a very few things that I know you'll come unstuck with. So I'd rather than write a static analysis tool, fix those cases. If I
yes, anyone who makes this tool will be famous on GitHub.
And
You're welcome.
I will write the book. Yeah, to know more about native image.
Yeah,
okay.
yeah. The book is also the thing.
Yeah. Well, I have one more question from in my direct message. If this a new technology, what are the risks for you for it's to use in production?
So I mean, so this is to me, this is a totally. I mean, the apps look the same, the code looks the same, but it is a different paradigm. We're not talking about just more of the same old thing, right? It's like moving from, I don't know, .war to .jar, moving from .ear to containers. It's just a whole thing. There's a whole galaxy of things that could go wrong, but there's also a whole galaxy of things that can go right. That's why I'm so excited about it. But yeah, there's so many. Of course, there's risk. It's a new technology. There's some things that may not be well supported. It is possible to get code that is different in production versus what you actually tested and compiled against, because the build is slightly different because of things that get swapped out.
That's when I was talking about the testing story. That can really help reduce the risk if you could have much more confidence in the native image that came out of that process.
Oh my God, I just realized. What if you created a framework that was meant to test things that are running inside of GraalVM and we called it JUnit?
JUnit?
There's a song. Never mind.
I thought there was one. It may be G stand for Google. No, that's G-test. Don't worry.
Okay, nice idea.
Yeah, I have an addition. You may notice that then you get your kind of regular GraalVM build, or you get an Liberica Native-image kit. You're getting it based on LTS release of Java. That's because at least fix what won't break as much as many parts as you can to something that's more stable than the part that's changing that has more risks.
Yeah,
that's why it's made so. Otherwise, you will get random bugs from everywhere. And
I have a question, Dmitry. What do you know about Leiden, Project Leiden?
It's interesting. Recently, there was. Sorry, I was thinking of Lilliput. Yeah, for Leiden, I didn't hear really kind of big updates for past few months. The intent is again to adapt what Substrate offers and to merge them with Hotspot. There are some technical issues with DLL sizes and other stuff.
But isn't this interesting? Leiden is an indication that what this is doing is going to become part of the mainstream approach. So yes, there's risks, but when you've got the Spring team, you've got BellSoft, you've got Oracle, you've got the JDK team itself, you've got all these people working on all this stuff, working on it. I have no doubt it's going to be, worth doing. I just don't know, how that stands right now versus next week versus next year.
Okay. Dmitry, something to add?
I think no.
Okay.
That's a complex topic because that's how the VM evolves itself in a very radical way.
Well, let's try to find the last questions because we have already a lack of time. The next question will be general. Can we say that native image is the new era in Java?
Yes?
Why?
Yes, I think
yes
so.
And no. Yes and no.
Well, Dmitry, let's start. Why yes and no?
Because ahead of time compilation is here all the time. So it's just a new implementation that works this way. Right? But AOT is a well-known kind of optimization for Java runtime, and it just wasn't used in this new area of like cloud computing.
Do you remember Excelsior? Or
Sure.
no, Exceljet, something like that. Wasn't that? Didn't they do an AOT thing? Well, yeah, that one. So it's been around. The idea has been around for a long time. It's just it's really gaining traction, like you say. There's stimulus. There's things like cloud computing that have motivated it. But I do think that the Java we have in 2021 is no kidding, the most exciting thing the JVM ecosystem is the most exciting it's ever been for me personally. Just I'm not speaking for anybody else, but core Java is amazing. What we have in the native image space is amazing. I mean, this is all now. I personally am looking forward to having an answer to people who are trying to use languages like Go or something like that, right? Or now it's like, well, maybe there's benefits, but maybe there's not. This takes the JVM code base and ecosystem into a brand new space that didn't exist before, for certain performance use cases. That's amazing.
Okay, Andy, something to add?
Really, I agree with the guys. AOT's been around for a while. I've never seen it quite push this far and this well, I think. So now we're in this world where we're working in microservices, and suddenly every little part of your app is almost paying the price of a JVM. So if you can get those efficiency gains with it's very compelling.
By the way, what you just said is a great point. Microservices, if you have a giant monolithic application, there's more surface area that needs to be compiled into native images. That means first of all, it's going to be more complex. You have to sift through more things. Also, there's more build time. So now if ever there was a reason to decompose into small services, this is it. Now you can compile one little thing at a time, easier to fix and get it working, and then move on.
Okay, I actually agree with you. Well, I think it's our last questions, and I would like to thank you guys for all your presentations and this Q&A section, because we have really a lot of questions there. They were, I think, quite difficult and different, and I think you were really cool. Thank you.
Thanks.
Well,
Thanks.
I hope
so
to
much.
see you in others on our one other conference of JRush with the different themes, different topics. So hope to see you soon, and have a nice day for today.
Yeah, stay safe.
Bye.
Yeah, stay safe.
Bye.
And thank you. Well, now we are finishing our first conference. I will be really glad if you can send me some feedback about this conference, about the speakers, about their materials. By the way, after the conference, we will send recordings, presentations, and other materials. We will send it to all subscribers by email. You will have something like a special page where you can find the videos with every speaker and Q&A section too, and can download all the materials. So thank you so much. Try to use all the products that we were talking about today, like Spring Native and Liberica Native Kit and so on. Thank you so much for all your questions. I hope we do as much as we can. Sorry for those who we didn't answer, but you can duplicate these questions to the Twitter, the personal Twitter of guys, or to our BellSoft Twitter, or via email. And thanks for our partners and all their company that created this web conference, JRush Group, BellSoft company, and VMware Tansu. Hope to see you soon, and have a nice day.